Okay, podcast 2.3, talking about electron configuration, which should just be helping us figure out how the electrons are arranged in the atom. And we're going to be a lot more detail than you probably care about. But this is going to cover pages 8 and 9, so let's get rolling. The Bohr model of the atom was really one of the best models for a long time. It showed that electrons orbit on clearly defined rings around the nucleus. Very predictable paths, but then some guy, Schrodinger, came along and did some math and got some fancy equipment to say, well, these electrons aren't always in nice circles. Some of them are, but some of them aren't. You can see all kinds of crazy shapes here. These were some measurements he took from some machines, and he did a lot of math with them to come up with the idea that the atom looked a little bit different, not nice, clearly defined rings. Schrodinger came up with the electron cloud model, that there aren't set orbits, just areas where you're most likely to find the electron, and they aren't necessarily going to be orbiting in nice, smooth lines. No predictable paths. So this kind of threw people through a loop. And so let's get to learn some of those crazy shapes that are in this quantum model of the atom. First, there's P, X, Y, and Z, but really those are just all P orbitals. So we have 4 different shapes: S, P, D, and F. S-shaped orbitals are spheres. P are these peanut-shaped. D is kind of a daisy. It's a dinky daisy. F is a lot more flowery, although sometimes they get a little bit freaky. So make a quick, simple sketch of these 4 orbital shapes that we can have. And then I actually want to show you that these aren't all of the shapes necessarily. These are the 4 main classes of shapes. In a set atom, we've got a lot more differentiation in the shapes. But if you look at these P's, the biggest difference between a lot of these is just the direction, the orientation. So this is why we had those 3 P's written out there, because one of them is a P that follows along with the x-axis, one's on the y-axis, and one's along the z-axis. So it's just 3 different orientations of the same shape. We do see some pretty crazy shapes as we start getting down into those D's and F's, but these are the 4 shapes that you need to be familiar with in order to be able to identify them. If I gave you 1 or 2 of these on the test, or maybe all of them, you should be able to identify them as S, P, D, or F. One of the little things that I want you to note, though, is that in the last drawing, there was only one S, only one spherical orbit in a set atom. In the P's, we had 3, those X, Y's, and Z. D's, there were 5 different orientations, and F's had 7. So that's how many different P orbitals, D orbitals, and F orbitals there are for a given atom on a specific level. And each of those orbitals can hold 2 electrons. So that means in total, an S orbital, or kind of a set of S orbitals, can carry 2 electrons. P's can hold 6, D's can hold 10, and F can hold 14. And we'll see and hear those numbers again a little bit later, but that's where they come from, is from these different orientations. So, no, SPDF 1, 3, 5, and 7. This is just a quick recap. It's kind of the same things we set up above, comparing them to each other. Bohr said that there's particles rotating around like planets, but they don't orbit in predictable paths according to the quantum model. They're treated as waves, and they just have these areas of probability. So you don't know exactly where they are and where they're going at any given time. Also, the stuff at the bottom of the page, don't worry about that. This is just instructions for how we could find a specific address for each specific electron. They're each going to have their own unique combination of principal quantum number, magnetic quantum number, angular quantum number, and spin quantum number, but that's way more than I need you to be able to do. So it's just kind of telling you each electron is unique and it's going to have its own address. What we're going to be doing is describing where and what types of electrons there are in all of the atom, not just describing any one. So I was actually going to pull up this video instead of this small little version of it here, so you could see as this atom of scandium is being built with all of these layers coming in over the top of each other. So this is a 1s, so you can see it's S, so it's spherical coming in. That's the first tiniest orbital. And the second energy level also adds an s orbital, but it also has some p orbitals. And you see these 3 different p orbitals starting to come in, and they're same shape. They're just going to align themselves with different axes and overlay themselves. And each of those it makes the atom look more bumpy on the outside. Those are each areas and places where other atoms can come and bond. And I'm going to speed this up a little bit so that we can see that coming in and not have to wait forever. But I want even faster. Can I do that? Okay. But you can see that depending on which orbitals that atom specifically has, the atom's going to look different on the outside. And it's really the biggest, outermost orbitals that are going to determine what an atom looks like, not necessarily the inner ones. So let's jump back to this. And the important thing to know is that the shapes of these orbitals correspond to the position of that element on the periodic table. So let's flip the page and look at the periodic table at the top. I know yours has a lot more writing around it, but I don't need all of that. I just have some stuff here that we need to add to that outline. So we have those 4 shapes, S, P, D, and F, and they actually each have their own block of the periodic table that they correspond to. So these first 2 columns over here at the left are called the S block, and it is a full block. You see how mine's a rectangle, yet underneath it there was kind of a little space missing? That's because this S block does have a little piece missing. It's hiding over here. That helium is part of the S block. It does belong over here with those first 2 columns, but we put it over there at the last column because it has a lot of similar properties as those noble gases. So don't forget about that second little S in that first row of the S block there. Our P block is over here. D block is what I called the ditch way back in the day. And then we've got our freaky little F blocks down there. Remember how hard those were to draw, and they kind of break a lot of rules once we get down there. So we got those F block elements that a lot of times we just forget about. So these are the blocks where you could say if I have an element that's over here in the P block, it probably has a lot of those P-shaped orbits sticking out in lots of different directions, lots of areas for things to bond with. So it gives you a little idea about the general shape of the atom. But these actually build up on each other like we saw in that last video. And so it's not just going to have one type of orbital, it's going to have a mixture of a lot of them. And so what we're going to do is describe each of the electrons and each of the orbitals on each of the levels, and it's going to seem kind of crazy, but what we need to know is that the S block starts at the first energy level. That's going to be the 1 S's. The P block starts at the second energy level of the atom. So second energy level has a second shape. Third shape is our D's, get added in at the third energy level. And the F's start at 4. So these are 4 different shapes, S, P, D, and F. We need to know where they are on the periodic table and where each of them starts. Now, you'll see, not in that big periodic table up top maybe, but in the little one down below, that I continued these numbers. Underneath the 1s is the 2s, 3s, 4s, 5s, 6s, 7s, because those are the different energy levels of the atom that each have s orbitals. Same over there with the p's. There's underneath 2p is 3p, then 4p, so on and so forth. So that's the minimum that I like to have as we're getting started. I'd really suggest that you look at that little map that's over there that just has this information on it, because that's what we need in order to be able to write out electron configuration. Now, electron configuration is going to be a sequence of these terms. Remember that 1 is the energy level, orbital shape is whatever letter is there, S, P, D, or F. And then we're going to add little exponents to it. This little 2 tells us how many electrons are in that shape orbital on that energy level. And for us, using a periodic table as a map, we're going to be counting the number of electrons in those spaces by counting the number of squares that we go through in that specific block on that row or energy level. So we're going to be having lots of these little 1s2 terms. And let's just get started, because the best way to see this is to do it. So This asks us to find the complete electron configuration for specific elements. The first step is to find that element on the periodic table. And H is easy. It's the first one right there. You're going to be starting. This electron configuration is almost like writing out someone's address. And we always have to start from the beginning. We're always going to start from the lowest energy orbitals. That was that Aufbau principle I kind of skipped over. Didn't have anything to write down. But we always start from the lowest energy, the 1s orbitals, and we build up into our full atom. Now, hydrogen only has a 1s orbital, so that's all we're going to have to write down there. But remember, we need to put an exponent on it, telling how many squares into that periodic table we had to go to get there. Well, that's just the first square, so that's 1. 1s1 is hydrogen's electron configuration. Well, what about helium? Helium is over there. Remember, we pointed out it's part of the S block, but it's hiding. It's kind of run away. Well, if I start from the same place, because we always have to start from the lowest energy orbital, the first block on the periodic table, that's a 1s orbital. But now I'm not just going to the first square. I have to keep going into that second square of the 1s's. So I'm going to label that as 1s2. There's only one type of orbital, but this time I have 2 electrons in it instead of 1. It's the difference between hydrogen and helium's electrons. Now, even though we're going on to lithium, which is on the next row, we still have to start from the same place, from the 1s orbital. And we're going to go all the way across any row to get to the very end of that row before we go back to the beginning of the next row. So I have to start with 1s2. I have to go through H and HE, both of those first 1s boxes, before I can come around and get to this 2s, where lithium's at. And how many squares into the 2s do we need to go? Just 1. So lithium is 1s2, 2s1. Beryllium is right next to lithium. We still start the very beginning every single time. First step is always going to be 1s, usually going to get a 2 on it. I'm going through 1, 2 to get there. Then as I come down through the 2s, I don't just stop at that first square, I have to go to the second. So beryllium is 1s2, 2s2. Quick little side note, in order to check your answers, especially on these little short ones, you can add up these exponents. As long as we're dealing with a neutral atom, the number of electrons, which is what that exponent represents, should be equal to the atomic number. So beryllium's atomic number is 4, and 2 plus 2 equals 4. So I've got all of them allocated, and I'm just hoping they're in the right places. I think it'll start to make more and more sense as we do longer and longer ones, because those first ones are almost too simple. So nitrogen is a little bit farther. Remember, we have to start from the very beginning. We always do. And like I said, this is kind of like giving directions on how to get to that specific element where it lives in the periodic table. And while it might seem a little redundant to say, walk out of your house, go to your driveway, like go down your street, like it's the same stuff that you do every single time. You probably don't need those directions. This is giving all of those directions, very, very thorough. So we always start with that 1s. And we're going through both of them this time to get through the whole first row. Come back to the second row. The first thing we hit is that 2s. But this time I have to go through both of them in order to get over to that P block. So that's going to be 2s2. Don't be confused and say 2s5, because these boxes over here that I am going to want to go through are 2p boxes, not 2s boxes. So I have to switch and label those separately when I go to a different set of orbitals, even if they are on the same level. So 1s2, 2s2, then 2p. I have to go to 1, 2, 3 squares in order to get to nitrogen. So this is nitrogen's electron configuration. We just keep going row by row from the beginning until we get to our elements square. So let's do magnesium. Starting at the beginning, I'm not going to draw my arrows this time because I get in the way. 1s, 2, and then going to the second row, 2s, 2. Now don't make the mistake of jumping down to 3s right now. That's where we want to end up, but we have to finish out the second row and go all the way across to those 2 p's. And if we want to go through all of them just to get to that third row, there's 1, 2, 3, 4, 5, 6 total squares there. Gets us done with the second row. Now we go back to the beginning of the third row where we see the 3 s's. And in order to get to magnesium, we need to go 2 squares in. So that's our process. Iron is going to be a bit farther down, but that's all that we're really adding here. Is after you get to know your map, it's just about using it and following through with these directions. So I'm going to start with 1s, 2. Go through the entire second row, 2s, 2, 2p, 6. Have to go through the entire third row too, 3s, 2, 3p, 6, then 4s, 2. Almost there, and that's when I see this weirdness happen. 3d? What? Mrs. Gunter must have made a mistake when she was labeling this. I didn't. This is not a typo. The 3D is actually at a higher energy than the 4S is, even though it's on the third energy level. It's weird. There's math involved. You're not required to do the math. You just need to know S's start at 1, P's start at 2, D's start at 3, and F's start at 4. And if that's the case, then it just so happens that the 3D lines up after the 4S. We just follow through, write what you got in the order that it's given to you, and just keep going through your process, even though it seems weird. 3D is the next thing that I hit there, and I have to go through 1, 2, 3, 4, 5, 6 spaces to get to iron. So this ends as 3D6. That's its configuration, no matter how weird it seems. Now, gold. Gold is going to, of course, throw one more little twist at us. I'm going to go through this first part because we have to get all the way through the 5th energy level before I even start thinking about what craziness might be happening with gold on the row that it's on. So I'm going to come down through this entire 5th row and then I'll slow down. Starting from the beginning, of course, with 1s, 2, 2s, 2, 2p6, 3s, 2, 3p6, 4s, 2, 3d10, if I counted those. 3, 4, 5, 6, 7, 8, 9, 10 total to go through. And then that lines up with 4p, back to going through all 6 of these. 5s, 2, 4d, 10, 5p, 6. Okay, that's the 5th row. That's where I said I was going to get through quickly so we could talk about this last row. Gold happens to be evil. No, it's not. I'm sorry I said that. Because it's on the 5th row of the D block there, the 5 Ds, we actually have to go through the Fs first, because this F block should be inserted. If we cut the periodic table here and separated the S's and the D block and shoved those F's in just at these last 2 rows down here, that's where they technically belong. We just don't put them there because they get in the way. But as I'm going across this 6th row, I'm going to have to do my S's and then go across the first row of my F's, and then I can come back and go through my D's. So there's little kind of symbols there trying to show you and beg you to go back through those F block elements first before you finish out those 5 Ds. You just need to listen to them. So we're going to start the same way, 6th energy level, right after 5p6, 6s2, but then after that, we're going to go to this top row of the Fs, which is our 4F. Once again, Fs get real freaky with those numbers. It seems like we're going out of order, but just follow through. If I count those, it's 1, 2, 3, 4, 5, 6, 7, 10, 11, 12, 13, 14. 4F 14, and then I can come back and continue where I thought I was. 5D, 1, 2, 3, 4, 5, 6, 7, 8, 9. finishing that out. So it's really just about being systematic, following your map, and not doubting yourself. I do want you to try and do silver for me. That is right above gold. So you're not going to have to go through the F's. It's a little bit shorter, but it's a little longer than iron. So do your best. I want to check that, see your attempt in order to get your stamp. Okay? Good luck. I'll see you tomorrow.